Hi, my name is Shivam Dhananjay. I am from Government College of Engineering and Research outside Khurda. I am presenting a embedded system project for internship called Micro One Simulation. The topics I have learned in this project are C language, which includes the conditions, loops, arrays, strings, and pointers, and macros, and many more functions of the C. I have also learned about the storage classes. For embedded system project, I have used the microcontroller called PIC16F77A. For the coding part of the C, I have used MPLabID and I have used the X8 cross compiler to compile our host and target together. I have used the PICSimLab simulation software to run and execute our project. At last, it includes the demo and presentation of the project. The requirements of the project are obviously microcontroller and microprocessor, PICSIM lab simulation software, CLCD that is a LCD display, matrix keypad to give the input, ISR that is a interrupt service routine, and the timers. First of all, the question arises, what is micro oven? We all know that micro oven is a kitchen appliance that cooks the food by passing the electromagnetic wave through it. There are several modes in a micro oven. In this project, we are going to implement four modes as follows. First is micro mode, second is grill mode, third convention mode, and four start mode. Let's have a look of them one by one. First is micro mode. This mode is used to cook the food in a traditional way. It uses maximum power of 900 watt. Second is grill mode. This mode is used to cook the meat and bread. It is same as micro mode. Convention mode. In this mode, user can set the oven to preheat for a particular temperature and it takes 3 minutes to preheat the oven. The maximum temperature user can set is 1800 degrees Celsius. After preheating is done, the user can set timer as per the requirement. Start mode. Start mode, we all know that it is a default mode. Whenever the user presses it, the timer is set for 30 seconds. The requirements of this project are MPLab XID, that is a for C, the X8 cross compiler, PICSIM lab simulation software, PIC16F877A microcontroller, 16 by 4 CLCD display, matrix keypad for giving the input, and the timer too. And this is a overview of PICSIM lab simulation software. In this project, I have also learned about the difference between microprocessor and microcontroller. As we know that embedded systems with the help of microcontroller are designed for the specific task, but the processors can be used generally. For example, our mobile phones contains the Snapdragon and MediaTek processors. They are for general purpose, but the embedded system, for example, washing machine, oven, they are not general purpose. They are only designed for that particular task and particular application. As we know, the processing power of processor is high, but the processing power of microcontroller is low. But the power consumption of microcontroller is also lower than the microprocessor. The size of microcontroller is also lower. As we know that in our microcontrollers in the embedded systems, we have only small amount of memory available. So it is more feasible to for lower price, and it is cheaper. There is no need to interface external peripherals in case of microcontroller. If we need, we can implement it, but in case of microprocessor, there is a strict need of external peripherals, that because it does not come with any output pins. It comes with input output pins, but it doesn't come with external peripherals. So we are using the microcontroller called PIC16F877A in this project. We also use the matrix keypad. The matrix keypad is used when more number of inputs are required. Here the columns are outputs, and here rows are output and columns are input. Here, if we have to uh, on the switch 5, then we have to ground the row and provide 0 1 1 input to switch on the switch 5. Uh, this diagram shows how the structure is created for the matrix keypad. PICSIM lab architecture. The PIC16F77A microcontroller can here interfaced with the RS232 LEDs, that is output buzzer, to indicate that task is completed, digital keypad, SSDs, matrix keypad to provide multiple inputs, CLCD display to indicate the mode and the temperature, or what timing is set. That is also output device. GPIO, that is general purpose input output pins to interface with the PIC16F77A microcontroller. Here there are many protocols, I2C, RTC, EEPROM we can use. LM35 temperature sensor is also used to detect the temperature of micro oven. ADC. ADC, we all know that analog to digital converter is used to convert the analog signals of temperature sensor to digital signals to understand the microcontroller, that is a machine understandable language. CLCD display, the characters liquid crystal display. In PIXIM lab, there are two types of display, 16 into 4 display and 16 into 4 display. Here we are required to give 4 modes of input. Therefore, we have used bigger display called 16 into 4 display. It displays all the ASCII characters and some of the special characters. There are two types of communication modes, 4-bit mode and 8-bit mode. Interrupt service routine, ISR. An ISR is a software routine that hardware invokes in the response of interrupt. ISR attends the request of an interrupting source by clearing the interrupt flag and should save the register contents that may be affected by the code in the ISR. When an interrupt occurs, the MPU completes the instruction, executes then, and it disables the global interrupt enable, places the address from the program counter on the stack. For example, our code is executing, and in middle of the execution of code, the interrupt arises. Then the ISR function get executed. Then the flag for interrupt is set. After that, flag is become zero after execution of ISR function. Then only our main code is executed from where it's left. In this way, ISR, that is interrupt service routine, works. Timers. Timer is an most important application in any embedded system, when which is a default peripheral which maintains the timing of the operation in sync with system clock or external clock. It has many applications like it can be used as a counter to generate a delay. There are three types of timer in PIC 16F77A: timer 0, timer 1, and timer 2. But in this case, we have used the timer 2 because it contains the TMR2 register, which is most suitable for this project. This is a interface of a PIC's SimLab software, which is a simulation software, which includes the 16 is to 4 display, cooler, heater element, buzzer to indicate the mode is completed. There are 4 displays available here. The matrix keypad is 4 by 3 keypad. Here are 16 LEDs available. There is a reset button to reset the microcontroller. PIC 16F77 microcontroller is also there. It includes WEP-ROM, RTC, and there are enable switches to enable the ports and many more pins of the microcontroller. Here we have used port D, port B, and many other ports for to interface the microcontroller that we will see in the execution and demo of the code. So let's go to the execution of the code as follows. Here, let's build our project. Here we can see build is successful. That is our code is wrong and hex file is getting created. So in PixSimLab, let's load the hex file. When we press the switch, hex file gets loaded and micro one is powering on. Here are 4 modes in the micro oven: micro mode, grill mode, convention mode, and start mode. When we press the one, micro mode gets started. Here the maximum power is 900 watt. Here we can set the timing for the micro mode. By by pressing the star, we can clear the timing. By entering hash, we can enter the timing. For pause the timing, we have to press 5, and to start, we have to press 4. When the second is grill mode. By pressing 2, we can start the grill mode. Here we can set the timing in terms of seconds and minutes. By pressing star, we can clear the timing, and by pressing hash, we can enter the timing. By pressing 4, we can add extra 30 seconds to the timing, and by pressing 5, we can pause the timing. By pressing 6, we can stop the timing. Pressing 3, we can start the convection mode. Here we can set the temperature. By, by pressing star, we can clear the temperature. By pressing hash, we can enter the temperature. If we set the temperature below 180 degrees Celsius, then the oven will set to preheating mode. Let's enter 123 degrees Celsius here. Now the oven is set for preheating mode for 180 seconds. After the preheating mode is over, we can just set the timing for micro oven. At the end of this timing, when this timing completed, the buzzer will ring. That indicates the food is cooked. Now our fourth mode is start mode. Here the default timing is set for 30.